Hi everyone, I am Parthu Reddy and today I am very excited to walk you through our project Court-MOE. In a country as vast and legally complex as India, building an AI that can truly understand and analyze court judgment is not a small task. That's exactly the challenge we are taking on with the Court-MOE. It is an AI system designed specifically to predict legal judgment outcomes within the Indian judiciary. So let's dive in and see what we have been building. Court-MOE stands for Mixture of Experts, and it is a model architecture we have developed to handle the wide range of judicial reasoning styles across different Indian courts. Our main goal is very simple. It is to accurately predict the final outcome of a court case, whether it is accepted or rejected. It is truly based on the text of the judgment. We are training this model on a powerful and much needed resource called as a Nyanamana dataset, which I'll talk more about in a moment. But before we go ahead, I want to quickly I want to quickly acknowledge the amazing team behind this. This has been a true collaborative effort, and none of this would be possible without their dedication and their hard work. To understand the dataset and our innovation, at the heart of our project, it is a Jnanamana dataset. It is a large dataset of a real court judgment from across the Indian judiciary, covering everything from the Supreme Court to high courts, district courts, tribunal courts, and even a daily order courts. Why is this very important? Because until now, there wasn't a unified, label, and structured dataset like this for the Indian legal judgments. This dataset fills a critical gap. Now, what makes our project unique is that we are the first to apply the mixture of experts model to Indian legal outcome prediction. That's a big step forward, especially in terms of specialization and performance. So, what problem are we actually solving? Well, the Indian legal system isn't just huge, it's incredibly diverse. Different courts use different styles, terminologies, and legal context. Most existing AI models try to generalize across everything, but that just doesn't work well here. By using a mixture of experts architecture, we are designing a system that adapts to these differences. It chooses specialized models or experts trained for the specific code types that leads to the more accurate predictions and deeper legal understanding. Why does this even matter? Because better prediction models can help lawyers prepare cases, assist common citizens with legal clarity, and even support policy level decisions. Here is what we have chosen to focus on and what we have left out. To keep the project focused and achievable, we clearly define what is in and out of the scope. We are building an MOE based model that uses legal but for the tokenization, and a smart router selects among the experts trained for the five code types. The prediction output will be binary, which is accept or reject. We are not integrating this proprietary or the external databases, and we are also keeping the scope limited to the Indian judiciary. So no international legal data for now. Now let's talk about how Court MOE actually works. Think of a model as a team of legal experts, each one trained to specialized in the one type of a code. The system starts by identifying the code of an origin. Then a Campbell softmax router dynamically selects the two most relevant experts network from this case. These experts analyze this input independently and their predictions are combined using the weighted fusion to produce the final decision, which is accept or reject. This dynamically specialized selection makes our model more accurate and adaptable than traditional single model approaches. Before I dive into the technical details, I want to highlight something that's central to our work, which is ethics. In a field as critically as law, technology must be guided by strong ethics. Our work is built on three pillars. First, ensuring algorithmic fairness. We are committed to upholding integrity and actively mitigating bias in our AI algorithms. Second, data security and confidentiality. We treat all legal data confidentially. And third and most important, which is a model architecture. This is our architecture. First, raw legal documents undergo LoRa conversion for the structured dataset. Then, the text is processed to the tokenization along with the legal but WordPress tokenizer for the token IDs for the specific legal domain. From there, a 12-layer transformer with 8 multi-layered attentions and along with the 768 hidden dimensions generate the contextual embeddings from the tokens. The core of our architecture is the next step. A Gumball softmax router selects the topmost relevant experts for the input. This dynamically activates specialized experts trained for the five distinct legal domains. Next, aggregation. The outputs from the selected experts are then combined through the weighted fusion, usually weights provided by the router. Finally, the linear layer with the softmax function classifies the result into two categories, which is reject and accept. Here is what coming next. The Indian judicial system is poised for significant transformation driven by AI, and we see our work as a direct and meaningful contribution to this future. By our next milestone, we'll plan to demonstrate a fully trained prototype complete with a robust inference pipeline and preliminary results. We are confident that this specialized architecture will showcase significantly improved accuracy compared to existing baseline models. Thank you.